Can you hear me? Yeah. So last time we discussed the capacitors, right? And we were going to the dielectrics, what's their role, and we defined the relative permittivity and capacitors when there is a dielectric. Relative permittivity for capacitors is also called dielectric. Okay. So we have a question that's exam related question. A material has a permittivity of 1.99 times 10 to the power minus 11 femto per meter. Calculate its relative permittivity. Okay. So if we need to calculate the relative permittivity, solution. The formula is very simple. It says that epsilon relative is equal to epsilon for medium divided by epsilon naught. Now epsilon for medium is given, but epsilon for vacuum, that's epsilon naught. Let's just write it here. We know it from previous chapter is 8.85 times 10 to the power minus 12 farad per meter. Okay. So farad per meter can also be written as coulomb square per Newton meter squared. Okay, or farad per meter. So we need to substitute these values now. So relative permittivity will become equal to 1.99 times 10 to the power minus 11 divided by 8.85 times 10 to the power minus 12. So 8.85 and 1.99, this will be 0 point something. Okay, and when this goes up, it gives us 10 to the power plus 1. So if you solve them, just divide 1.99 divided by 8.85. I got 2.25. Yeah, 2.25, because it will be 0.225, but then 10 to the power 12, so we multiply it by 10 and it goes to 2.25. And what unit should I write with relative permittivity? There should be no unit, because it's the ratio of the same quantities. So when it's a ratio of same kind of quantities, there should be no unit. It's a dimensionless quantity. Okay.